So we have this very interesting problem before us. At the first glance, it might look as if the question is so complex, but however, with some twist, you say that it's a very easy problem to solve. Now, if you look closely, you see that the power of 9 here is 1 plus logarithm of x to base 3. And similarly, the power of 3 is also 1 plus logarithm of x to base 3, which is similar power. So a good start would be to represent this power with another variable. Say that, okay, we will say let um, u be equals to 1 plus logarithm of x to base 3. So we could use this assumption. So with that, we will say that we could rewrite this as 9 to the power of u minus 3 to the power of u minus 210 equals to 0. Okay? Now, we could write 9u in terms of 9 raised power u in terms of 3 raised power u, such that because 9 is 3 raised power 2, so this becomes 3 to the power of 2u minus 3 to the power of u minus 210 equals to 0. All right, this is a quadratic relationship. But in order to make it much more simpler in view, we could also say let um, 3 raised to power u represent another variable. 3 raised to power u represent another variable, let's say y. With this, we will see that 3 raised to power 2u is nothing but what? Y squared. Okay? So from here, we will see that the equation can then be rewritten as y squared minus y minus 210 is equals to what? Is equals to 0. And this can be factorized because we could look for two factors that multiplies to give 210y squared and adds up to give minus 1. Okay? And such factors are uh, negative 15 and positive 14. So we could replace our minus y with y squared minus 15y plus 14y minus 210 equals to 0. Since minus 15y plus 14y is going to give us minus 1y, and a product of minus 15y and plus 14y is going to give us 210. It's going to give us minus 210y squared. Okay, so from here, upon factorization, we can see that y is common here. Y is y minus 15. That is, we group them into 2. Then this is going to be 14. It's common here. And we have y minus 15. Y minus 15 equals to 0. From here now, okay, y minus 15 is common on both sides. So we have y minus 15 is common to both terms. Then we have y plus 14 equals to 0. So from here, we could calculate what y is. We say that y minus 15 is 0, or y plus 14 is also 0. From here, we could say y is 15 or y is negative 14. Now we go back to the first assumption, the second assumption we made. Since we know what y is, now we can relate 3 raised to power u in terms of y, which implies that 3 raised to power u is 15, or 3 raised to power u is negative 14, right? Now, from here, we could calculate what u is. We could calculate what u is by, we could take, let's say, take logarithm to base 3 of both sides. of both sides. Now, why are we taking logarithm to base 3? Because our original expression is in logarithm to base 3, so it's much more easier to apply logarithm to base 3 to both sides, so that we can keep our logarithm in base 3, so that when we substitute, we'll be able to bring together the logarithms in terms of the similar base. So from here, if we take logarithm to base 3, we have the logarithm of 3 to power u equals to the logarithm of 15, both to base 3. Or we could have similar thing, logarithm to base 3 of 3 raised by u is equals to the logarithm of negative 14 to power 3. Now, since we cannot evaluate the logarithm of a negative number, so we will discard this particular um, other option of answer while we focus on this one. So now let's move on with this. From here now, remember that from your rules of logarithm, 3 logarithm of m raised to power n is the same as n logarithm of m, and logarithm of a number to the same base is 1. You could apply that here, such that logarithm of 3 raised to power u will give us what? It will give us u logarithm of 3 to base 3 equals to logarithm of 15 to base 3. So from here, logarithm of 3 to base 3 is nothing but 1. Hence, our u is going to be what? Logarithm of 15, logarithm of 15 to base 3. Now that we know what u is, we can now go back to the first assumption, or letting u to be equals to 1 plus logarithm of x to base 3. From there, we now say since u is equals to 1 plus logarithm of um, logarithm of x logarithm of x to base 3 is our u, and now u has been gotten to be logarithm of 15 to base 3. So with that, we have this is equals to logarithm of 15 to base 3. Okay, so what do we now have? We could now relate we could bring all the logarithms together, such that we have um, logarithm of 15 to base 3, logarithm of 15 to base 3 minus logarithm of x to base 3 is equals to 1, right? Such that using your law of logarithm, you recall that also the logarithm of a particular number to a particular base, let's say base n, minus the logarithm of another number, let's say q, to base similar base, is nothing but the logarithm of m divided by what? Divided by q, to that same base what? To that base, same base n. So we can bring this together, and we have the logarithm of 15 divided by x to base 3 equals to 1. Now, also recall that transformation from logarithm to indices, if I have the logarithm, let me write that in blue ink. Okay, this is 1. If I write that in yellow ink, we have logarithm of a number, let's say m, to base n is equals to q. This can be rewritten as what? M is equals to n raised to the power of q. This is transformation from logarithmic form to indical form. So we could apply that here, such that we now have the logarithm, okay, instead of writing that, we could have 15 over x will now be exactly equals to 3 raised to power 1. Okay, from here we have this becomes 15 over x equals to 3 over 1. If you cross multiply, you see that you have 3x is equals to what? Is equals to 15. And if you divide both sides by 3, you're going to have our x to be what? 5. So this gives us that x is going to be what? Is going to be 5. So the solution to the exponential relation we started with is um, our x is going to be what? Is going to be 5. So that brings us to the solution to that integral or exponential equation.